Sorry.
Oh, is this it?
Yeah.
So forward. Okay. Hello. I failed to have a fun lunch slide, but I will be moderately quick with this presentation. So I'm Christopher Palmer. I'm here to talk about Xbox One and the peer-to-peer networking behavior. We know from experience that end users who experience problems with peer-to-peer networking are frustrated with their experience with the console. They're frustrated with their internet service provider and with their networking setup. So we wanted to talk about Xbox One and its behavior before the upcoming launch to kind of sort of prepare the ecosystem. So the sort of flagship thing here is that Xbox One uses IPv6 with IPsec along with transition technologies to power the peer-to-peer experience. This is one of the central benefits of IPv6 is the promise of relatively simple peer-to-peer networking between end user devices. NAT and firewall, less of a problem. There are three sort of major ways that network operators and equipment vendors can make sure that end users have the best possible experience. Providing IPv6 connectivity is sort of the easiest in terms of words. Just do that, please. It's kind of perhaps complicated. If in the majority of networks where that's still not available, please let Teredo work. And then in general, to let IPsec transport mode to function. And we're going to get into a little more of the details behind all that. So when I say peer-to-peer in the context of Xbox One, it's generally one console communicating directly with another. You can think of like a synchronous gaming experience, conventionally like I'm fighting someone, I'm shooting someone in this map, like Halo kind of thing. Xbox 360 used a custom stun and security implementation. That's how peer-to-peer was offered with that platform. We did something different with Xbox One. And the reason why we did that was there was an increase in growth. IPv6 is less of a theoretical thing. And also there's a push in the industry around standardization. And so both of those things kind of came together to make v6 plus IPsec an attractive option for powering peer-to-peer. That positive energy kind of has to be contrasted with the current reality of IPv6 adoption. So this is some data we get from Bing, which currently supports IPv6. When you have IPv6 directly available to the end user device, it makes everything sort of pretty easy. But the reality is that, especially in the terrestrial market, I think there have been other presentations that have showcased data. IPv6 is not commonly available. There were some major events over the last 2 years that really try to push it, and it's slowly getting there, but there's a lot of room for growth, approximately 95% room for growth. Around last year, actually even earlier this year, there was less than 1%. Now we're seeing 2% effective IPv6 penetration. There's a difference here. The reason why I have 2 bars on this graph is because around 5% of end user devices we detect as having IPv6 internet access, but they don't seem to prefer it. And that's because of a lot of recent work around happy eyeballs and browsers. So a lot of browsers now will generally do stuff to race v6 and v4. And so sometimes v4 wins, and so there's a little bit of a difference between availability of IPv6 and is it the best possible way to reach a website. Some of that's not necessarily endemic to v6 or v4, but because of the maturity of things like CDN. So some folks have services that aren't necessarily CDN'd on the v6 side, so performance is kind of heterogeneous. Because of this, the dark reality of IPv6 being only around 2% effective, the reality is that Teredo is going to fill the gap. So Xbox One is going to use a lot of Teredo. It's going to mainly use Teredo because when you think about having a game and you have 16 players who are trying to fight, you're going to need not all of those guys are going to have IPv6. Not even, if we're lucky, one of them will. So, how to keep your users happy. So we're going to go through some of the technical details of Xbox One behavior and some of the advice that we'd like to provide to the general community. So the first one is around IPv6 networks. So the general IPv6 network and security space is still developing. It's something new. But there are a couple of key points here that we want to push. One is that to allow inbound IPsec traffic. So conventional firewall behavior where you simply block all inbound non-solicited traffic, please don't do that with IPv6. I mean, it massively erodes the value proposition. So there's existing IETF recommendations in this area that are specified in the end of the deck, but generally, please allow IPsec transport mode to function with the ESP option. That's what we'll be using, and inbound IPv2 traffic to negotiate the IPsec session. An additional aspect is that some end users, if they encounter problems, they'll want to enable transparent operation. So they'll want to go into their wireless router and switch a knob and just make things just kind of flow. And so that's another thing that we encourage everyone to sort of do. Provide an option that allows you to turn off firewall capabilities in your equipment. For the majority of networks that are predominantly IPv4, please allow Teredo traffic. So Teredo is a IPv6 transition technology that uses UDP to create a IPv6 address on the host machine. Conventionally, for folks who are running, some of you guys have Windows, you might see that you have a Teredo IPv6 address in certain locations, and that's what it does. In order for Teredo to work, there are a couple of key things. One is supporting outbound UDP with long port mappings. So if you have functionality like a firewall function that only supports, for example, outbound HTTP, that's going to break Teredo, right? And that's going to break peer-to-peer, and then users are going to be frustrated. Not only is supporting UDP important, but there's the further detail of making sure you support long port mappings. If you have a UDP flow and you have to send a packet every second, that's going to be lossy. So we generally recommend that port mappings persist for at least 60 seconds. The IETF recommendation, I believe, is 5 minutes. Xbox One, we're going to refresh port mappings about every 30 seconds. So 60 seconds, please, would be nice. In general, Teredo is sensitive to NAT behavior. So whether or not it's an open NAT versus an address restricted versus a port restricted NAT. Clearly, for the purposes of connectivity, the more open the NAT, the more likely the end user is to have a really great experience with peer-to-peer. In particular, don't block UDP, and symmetric NATs cause problems. So we have telemetry that shows the overwhelming percentage of NATs on the market today, that the overwhelming percentage of end user NAT behavior is open, address restricted, or port restricted. So we obviously feel pretty good about it, but symmetric and simply blocking UDP will cause problems. In general, Teredo, the Xbox One Teredo implementation is a little different from Windows in the sense that it will prefer a specific port for peer-to-peer traffic. So on Windows, we use ports from the dynamic range for Teredo peer-to-peer. With Xbox One, we'll generally prefer 3074, which is the same port used for Xbox 360 traffic. So if an end user has a port forwarding rule today on his home equipment, things will continue to work. If you have specific logic in your network around quality of service for Xbox traffic, and you base that on UDP port mappings, that will generally still hold. I say prefer because if you have multiple end user devices on the same network, there's obviously a port competition problem. So we have a fallback mechanism by which we will use other ports if 3074 is not available. Another trick with IPv4 networks is applicable for Teredo, but generally any stun technology, including Xbox 360. This was we reached out to a couple of networks that have CGN, in particular around this point, hairpinning. So if you have some sort of CGN infrastructure where you have 2,000 users behind a CGN, then clearly one of those users may want to play with another one of those users, and so hairpinning is important. Right? So you should be able to send traffic from my house to a peer, hairpinned through that CGN apparatus. Folks who are interested, this is the general packet format that we'll be using for peer-to-peer traffic. Again, it is protected with IPsec. And when I mean protected, I don't necessarily mean encrypted. So there's a difference. For the most part, we're worried about integrity and we're worried about authentication of peers. This is how the general packet format looks like with Teredo, which again is going to be the overwhelming majority of peer-to-peer traffic. You'll see there's a v4 header, there's the UDP header for the Teredo datagram, and then the IPv6 header and the ESP header. We will actually attempt to use IPv4 for direct connectivity between peers. As you would imagine, that's going to be an overwhelmingly minority case because most Xboxes don't have public v4 addresses. But it's generally for link local. So if I have two consoles on a Wi-Fi network, for example, and for some reason we don't have v6 on that network, or generally, we might use v4 for peer-to-peer connectivity. Another element actually that kind of comes up here is that if there are multiple paths between peers, for example, if IPv6 is an available path, Teredo is an available path, and native IPv4 is an available path, we're going to choose the path based on sort of performance metrics. So it's not a conventional RFC 3484 implementation where we always prefer native IPv6. It's going to be sensitive to performance, it's going to be sensitive to the service, it's going to change over time. Some more information. There's detailed documentation that's aligned to this presentation available online, so microsoft.com/IPv6. If you sort of web search it, you'll see technical information on peer-to-peer networking behavior. Hopefully it'll come up. The relevant RFCs for the recommendations and behavior that I talked about in this deck, they're all, we generally are relying on standards. It was a key part of the way we designed peer-to-peer was to rely on standards. And there are IATF recommendations for network behavior, including for IPv6 security, so allow IPsec. There's information on Teredo and supported NAT types, the connectivity matrix. And then there's, in the IPv4 space, there's recommendations on UDP behavior. So allow outbound UDP, long port mappings, hairpinning. The Xbox One will include a troubleshooter for end users that informs them of their effective NAT type. Some of you, if you've used an Xbox 360, there's a troubleshooter there as well. I say effective NAT type because we're going to look at the NAT type. The effective NAT type isn't necessarily the behavior of the end user's home router. If you have cascading NATs, or like a CGN-like deployment, the effective NAT type is going to be the final NAT in that path. Right? So if your home Wi-Fi router is just fantastic, but you have a CGN way up on the path that just kills all UDP, that's what we're going to report to the end user. Hey, your network doesn't support UDP. We do have telemetry in the console and on the service side, so we'll be monitoring any sort of geographic specific issues. Many operators have probably already been contacted by us for 360 escalations as well as Xbox One sort of preemptive chats. So we do have a system that kind of responds to end user state in the community, and we try to be pretty proactive about problems that we see. And that's really it. So questions? And there's an alias that you can contact us if you have any sort of questions.
Just before we go to the mics, one question came in on the chat channel related to the video stream, and it was whether Bing is available via IPv6 only.
I don't know what IPv6 only is a confusing thing. So there are quad A records for Bing, and you can access Bing generally through IPv6. There's also obviously a v4 node for 98% of the world.
Okay.
Hi, Christopher. Jeff Houston, APNIC. As you're probably aware, we've been testing users for the last few years for their Teredo capability by basically giving them a literal in their browser, which is a v6 address, and coincidentally, Microsoft boxes, if they don't have any native v6, activate their Teredo stack. We see a failure rate in these connections. The ICMP exchange has a failure rate of between 25 to 28%, and we're measuring around 150,000 people a day. In addition, even if it succeeds in ICMP, the initial SYN has a further break rate of around 12%. So in total, we see 1 in 3, around 35% of folk who have Teredo, give us the opening sequences of a Teredo session establishment and then die a horrible death. What's going to happen to these poor guys on Xbox? I have a second question, but we'll let the first one fly.
That's actually, I was 100% expecting this. So I knew this was going to happen. So Teredo quality. So we have telemetry too. I don't want to doubt your telemetry because I think you have a fantastic system, and we do look at your data. This is why I knew this was coming. So generally, we see that Teredo works peer-to-peer about 90% of the time. And I mean peer-to-peer, one Teredo peer talking to another Teredo peer. They're able to maintain a perfectly adequate connection. And so the quality of peer-to-peer Teredo as compared to generalized stun implementation, we feel pretty enthusiastic about it. There's a couple of points, though. I do want to give you credit. So one, we're watching it. So if we encounter systemic issues, we will change things. The second point is that we will not be using Teredo relays. So if you have a Teredo client and you have a native IPv6 client, we will generally not use that path. So we're going to avoid address family transitions as much as possible because there's a latency cost, there's a route flapping cost. So no Teredo relays. I think that should greatly alleviate the perceived persistence problems with Teredo.
So this is the second question. You're saying that the current issues where my, quote, local, quote, Teredo relay is some random location in Iceland or South America, you're saying won't happen in this kind of environment?
Yes. So let me.
Cool.
Okay, so let me just specify that. So there's two connectivity paths that Teredo supports. One is peer-to-peer, which Teredo behaves very similar to any IPv4 NAT traversal system. There's also this availability of Teredo to contact hosts on the IPv6 internet, and that uses a public Teredo relay that's supported by a lot of fantastic internet service providers, which I give special credit to Hurricane Electric in particular. They have these big Teredo relays across the planet that are very nice. However, those relays are not globally available, and they generally can cause very strange behavior in the routing path. So if I have a peer in Washington State and a peer in California, the relay might just happen to be in Chicago, and this weird thing happens, and so it's not great. So generally, we will be avoiding usage of Teredo relays, and we will be using either v6 to v6 or Teredo to Teredo, but we won't be doing Teredo to native.
So if I was to try and test this, I would put up my server on a 2001.032 address, right?
If you wanted to, your literal, you mean in your
Yes.
thing, your literal should be a Teredo peer.
Thank you.
Yes.
Okay, this will be the last question before we break.
David Farmer, University of Minnesota. So I have a different question, but you just raised one for me. So that means if I provide my students at the university a fantastic v6 service, they're still probably going to be using Teredo because they're talking to somebody who isn't using native v6.
So yes and no. If you have, say you have 10,000 college students and they're at university and you have native IPv6, for peer-to-peer traffic when I'm playing with my friend in the dorm across the street,
Yeah.
native IPv6 will very likely be used. So that will work. When you obviously have those college students playing with some folks over at some other college and they don't have native, then obviously we have a transition problem, and so Teredo will be used. Generally, I spoke of this earlier, the choice of which routing path to use is performance dependent. So if you have a really fantastic native IPv6 deployment, that'll probably be used, but the data we showed earlier in general, for a lot of end users, even if it's native to native, v4 is pretty speedy. And even in university environments, like I went to a college that sits on the entire 8/18 space, and it's speedy. And they don't, so, you know, like native v4 will still be used in a lot of cases too.
Okay.
So it's not a simple, we'll always prefer native. It's a little more nuanced than that.
Okay. Then my other question, I assume this thing has a Wi-Fi uplink on it. Will it support WPA2 Enterprise?
I will be honest, I don't quite know. I don't.
Because in a university environment, we require logon, and the easiest way to do that is WPA2 Enterprise, because when you share a secret with 100,000 people, it's kind of hard to call that a secret anymore.
That is awkward. I apologize, I don't actually know.
Okay, thank you.
Yes, so, sorry.
All right. Thank you very much, Chris. And we will break for lunch.